Okay, welcome. Today we're talking about rules for triangle congruency. A couple of those rules we could list: side, 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 angle, side, angle, um, angle, angle, side, and HL. These are your five main rules based on the acronyms. You know, if it says S, it's talking about a side. If it says A, it's talking about an angle. There is no ASS rule in or SSA rule and with triangle congruency, and we'll try to show you that towards the end a little bit. Just one thing I want to go over as far as like a prerequisite skill or something you need to understand is this idea of included side and included angle. And that's important because what will happen is you will have, so if you see you have, like in this case, here you have two angles and a side, here you have two angles and a side. But the idea and the understanding is that included piece is what's going to help you determine which rule it is. So what do they mean by, let's just say, included side? Well, if you have an angle here, let's say this is angle A and you have angle B. You have three sides. You have three sides to this triangle. There is only one side that you could consider as the included side, and that's side 2 here. This is the only included side. Now what that means is basically it's the side in between the two angles. And that's like an important skill. That's an important skill to, you know, to be able to determine which rule we're going to say triangles are congruent by. Let's look at it. Okay, we looked at included sides, so let's look at included angles. It's kind of the same idea. If I have two sides of a triangle, and you'll see these slashes as we go along, which is matching with which, you have three angles. 1, 2, 3 angles. But only one of these angles is included, and that's angle 2 here. And the reason for that is that is the only angle, basically, it's, you know, I don't know the exactly, or we'll just say the best way to get a child to understand this is the fact that it's exactly in between. Meaning like this angle here is not directly in between those two sides, those two orange sides here. It's actually in between, it'd be in between the purple side. So if you could see that, this is the included angle. One would be the included angle of these two sides. So be sure to pay attention to that. And then the other thing we want to take a look at before going forward, let's just assume this is a right triangle. This is your right angle. When we talk about the hypotenuse leg theorem here, the HL theorem, keep in mind that the side opposite the right angle is your hypotenuse, and the two sides that make up this right angle, this side here and this side here, we're going to go ahead and call those the legs. Those are the legs of the triangle, something you may have already known. So again, this kind of just discusses the included side, included angles. Let's look at the first rule, which is side, side, side. And let's say you had a congruent statement. Let's say we had triangle ABC and DEF. And we said triangle ABC is congruent to triangle DEF. Now, we worked with a congruent statement, and we understand that the order of the letters determines the order in which pieces are congruent. So if we're talking about sides, we know AB and DE, and we'll put a single slash for each, they're a congruent side. We know BC and EF, we know that to be another congruent side. And we know AC and DF is our last congruent side. And notice the fact that this side is congruent to this side, or DE is or DF is congruent to AC, I put a matching amount of slashes there to signify that. And basically what the rule is saying is that if I have two triangles and the measurement of all three sides are congruent to another triangle and their three sides, those triangles have to be congruent. In other words, there's literally no other way in which I can draw these triangles with matching sides and have them not be congruent. And we call this the side, side, side SSS rule. So you're trying to determine. Now, a good one they like to show is that they'll give you congruent side, congruent side, congruent side, congruent side, or they'll say B is a midpoint, which makes these two sides here and here congruent. And then you're sitting there wondering, what is this? Well, another little prerequisite kind of outside idea that you may not have been shown is this idea of a common side. If this triangle is sharing if these two triangles are sharing a side, then this side has to be congruent. So this is a good example of SSS in which there's a hidden common side, a hidden congruent side here with SSS. Next one we'll take a look at is the side angle side rule. And again, if I give a congruent statement, and I want to go through that on each one, and once you're done with your congruent statement, you've determined that you have two congruent sides, and an included angle. This is an included angle. It's in between the two sides. So if I had to determine which angle that would be, 1, 2, or 3, I'm going to say 3 because this is the angle that's exactly in between here. This is my included angle. Now what I like to do when working with these rules is I kind of like to look what I have congruent. I'll put an A or S right next to the parts that are congruent. So if you see here the side angle side, you can start to see that I have a side angle side rule here, which means if I have two triangles with a congruent side, let's call this a congruent angle, and another congruent side, so basically two congruent sides and an included angle, these triangles need to or will be or have to be congruent to each other. There's no way for me to draw two triangles with two congruent sides and an included angle and they not be congruent. Another one is SASA, which is kind of the same thing we just looked at with side angle side, but in this case we have a congruent angle, or let's say two congruent angles. Now notice I'm matching up the angles with the proper amount of arcs here. So this has one arc, this has two arcs, and because they both have two arcs, I'm saying they're both congruent. And you have your included side here. So if I have two triangles and they have two congruent angles, let's call this 85 again. And the included side is congruent, let's say it's both 10, then they by definition have to be congruent. That's an angle side angle there. And a great angle side angle you'll see is this one right here. Let's just assume these triangles kind of look the same. They'll give you a congruent angle here. They'll give you a congruent angle here. They'll give you a congruent side here and here. And then you're looking, and like I mentioned to you, okay, I'll do my labeling. Well, I'm missing a piece here. Well, we looked for a common side before. Now we have to look for a vertical angle. And the vertical angle here will reveal another congruent angle. We know vertical angles are congruent. So when we see something like that, we notice, oh, there's a hidden angle here. It's a vertical angle. So now I know this to be angle side angle. And you're going to see a lot of that. You're going to see a lot of hidden vertical angles and common sides. What have we done so far? We've done side, side, side. We've done side, angle, side. We've done angle, side, angle. Now we have to look at an angle, angle, side, which is two congruent angles and a non-included side. So meaning the side basically in order or right outside the two angles. So here I have an angle, angle, side in order, and here I have an angle, angle, side in order. Meaning if I have triangles with two congruent angles and a non-included side, I would say they are congruent by angle, angle, side. And the last I actually like to do is look at our HL. So let's look at a right triangle, because the only way we could use HL is using a right triangle. So let's look at that. And what you have to notice is that here, this side, let's say this side is 4. Let's put some measurements to it. Let's say, no, actually I'm going to use actual right triangle measurements here. Let's say this is 6, this is 8, and this is 10. But let's say what will happen is all you need is one leg. So they'll single slash the 6s and the hypotenuse. You need one of each. So here was your leg, and here was your hypotenuse. A lot of times when you see these congruent triangles and you see a right angle, you know, it more or less will be HL. You could also have an HL that's a SAS depending on what's given. You got to look at what's given to you a lot of times, because these are basically proofs, right? We're proving two triangles to be congruent. So look at the given and then use the given to determine which rule you're using the given. You can't just start making certain things congruent because they look congruent. You have to use what's given to you. Now, let's take a look at, okay, so let's again look at, I want to just finish up by looking at why angle side side or side side angle is not a rule we can use. And I'm going to show you that by demonstrating. So let's say this is 40 degrees. And I have a side here which is, we'll call this 10. I can actually make a triangle in which this is 8 as well as this is 8 here. You can make a triangle in which you'll have two congruent angles, a congruent side, or two congruent sides. So I have an angle and I have two sides, or I have two sides and an angle, but you see these two triangles are not congruent. So there is a way to basically what if you want to visually look at it, this 8 from this vertex can point to here, but I could also kind of sketch it and move it to here, and I could also fit that 8 side here and make another triangle with it, and that's why this side angle rule is not something we can use it as our rule of congruence. So again, there's a lot of rules here. You got to use what's given to you. Try to take the triangles and list, okay, they gave me a side, they gave me an angle, and they gave me another side. So I'm going to use, in this case, side angle side. That's basically what we're doing when we're going through this. Okay, little addition here. I actually was asked how do we know which angles and sides to use? So I mentioned about use what's given. So let's actually take a look at that where I'll say what you're given, or what you'll be given is angle A is congruent to angle D. And we're going to single arc those two to show that they're a match. And then let's say I have angle C is congruent to angle F, which now I'll say these two are a match. And then you're given BC is congruent to EF. So you'll put a single slash for these to show that they're a match. And then you basically look in order. Okay, I have an angle, angle, side. I have an angle, angle, side. So therefore, I'm going to use an angle, angle congruence rule to show that these two triangles are congruent. Now, if you were given instead you were given AC is congruent to FD like this, and they put the included side, they put the side in between, then we would say this is angle, side, angle. So since I gave you something different, you have to give me, in turn, a different rule. And let's say instead they gave you 1, 2, and then a third side where they said AB is congruent to ED. And now we have a triple slash for this here. And these are the three pieces that are given. You're given these three pieces here. Then we'd switch to the side rule, because now we're looking at, or we're being given three sides. I hope this kind of helps some of that understanding there. Just use what's given. Use what's given and come up with a rule. And don't forget about the hidden verticals and common sides. That's a big one. They're going to hide that quite a bit. What we need to look at is, well, what I